Using the characteristic equation we did for the previous video, using the same matrix here, we are now going to solve for the eigenvalue, the corresponding eigenvectors, and the representative eigenspace of this matrix here. Again, this was taken from a previous video. You might want to review that if on your own as to how do we get this equation here. Now we are going to simply use that to solve for the eigenvalues, because the eigenvalues are represented by the lambda constant here. Of course, we are going to use here a specific method in factoring this. So we can use here, or you can use factoring, but since this is a C coefficient, we can move it on the other side. Okay, lambda squared is equal to 1/4. And we take the square root of both sides. Please don't forget to use the positive and negative. So your lambda sub 1 is the positive 1/2. Square root of 1 is 1, square root of 4 is 2, and your second lambda is the negative 1/2. Okay? These are now your two eigenvalues for this given matrix. Now, these eigenvalues have correct and appropriate eigenvectors and eigenspaces. To do that, let's go back to the idea of coming up with this form. The lambda times your I minus a. Because this expression will be used later in solving for the eigenvectors. Of course, this is a 2 by 2 matrix. So we expect that our I here, being the identity matrix, is 1, 0, 0, and 1. So let's try to come up with this expression first. So you have lambda times identity matrix 1, 0, 0, 1 minus your A, which is 1, negative 3/2, 1/2, and then negative 1. You will have here the matrix lambda 0, 0, lambda minus 1, negative 3/2, 1/2, and negative 1. So your form here is this: lambda minus 1, 0 minus 3/2 is positive 3/2, 0 minus 1/2 is negative 1/2, then lambda times, minus a negative 1 is lambda plus 1. This is now our representative, our matrix that will be subjected to this form. You have lambda I minus a, which is that one, times a certain vector x equal to the 0 vector. This certain vector is a element of R2, because we have a 2 by 2 matrix here. So we have x sub 1 and x sub 2, and of course your 0 vector is the 0 vector of R2, and this is where you're going to place this entire expression. But of course, no more lambdas to be used. What can we use here? We are going now to substitute these two eigenvalues. So let's start with the first one. So in the first one, this would become equivalent to 1/2 minus 1 is negative 1/2. You'll have 3/2 here. This is also negative 1/2. And then 1/2 plus 1 is 3/2 as well. Okay, so this is to be used here, negative 1/2. You have 3/2, negative 1/2, and also 3/2 here. Now, using this, you can automatically analyze possible situations, because we have rows of the same entries, right? We have concepts of that before, but let's just simply continue. The goal here is to come up with the reduced row echelon form for this. So let's multiply negative 1/2 to R1 to have a new R1. And this would become, not multiply, not negative 1/2. We're going to multiply negative 2 rather, because our goal is to come up with the leading one in this form, leading one. So negative 2 times negative 1/2 is 1, okay? Negative 2 times 3/2 is negative 3, right? So we still have negative 1/2 and 3/2 here as well. Now, let's multiply. Here is, we are going to multiply 1/2 to R1 and add it to R2 to have a new R2. This is now 1, negative 3. So 1 half times 1, then minus 1 half is 0. 1 half times negative 3 is negative 3 halves plus 3 halves, another is 0. Once you reach this point, okay, we can now have an equation of x sub 1 minus 3x sub 2 equal to 0. So we have two variables now. We are going to let x sub 2 as an arbitrary variable t, so that x sub 1 can be solved in terms of t as well. So x sub 1 is equal to 3t. With this, our vector now, which comprises of x sub 1 and x sub 2, is the matrix of 3t and t. And if you're going to factor out t, you will have here 3 and 1. This is a more specific eigenvector, but of course you have a lot since t can represent other values. So we have here this, we can also represent this entire because we have the set containing all eigenvectors of a specific eigenvalue. We call it eigenspace. Simply copy that, t, R1, such that t is an element of R but not an element of the set containing 0. Or in short, it's not a 0. This is now the eigenspace containing all the eigenvectors of your eigenvalue, which is 1/2. Okay, so we are done with the first set. The next set is where we're going to use the next eigenvalue to this form. Okay, so we will have this when our eigenvalue is negative 1/2. Our matrix here will be negative 1/2 minus 1 is negative 3 halves. You have 3 halves here. Then you have minus 1/2. Then negative 1/2 plus 1 is 1/2. Okay? This now will be paired, just like this one here, this form. Okay? This is the form lambda I minus a. But you're going to multiply this with a certain vector x. Okay, and equate it to your the 0 vector of R2. So you will have negative 3 halves, 3 halves, negative 1/2, 1/2 times x sub 1, x sub 2 equal to 0, and then 0 here. So again, the goal is to come up with the reduced row echelon form of this. So let's try to multiply negative 2/3 to R1, so that this will become leading 1. Okay, for a new R1. So negative 3 halves, negative times negative 2/3 is positive 1. When you multiply to the next, you'll have negative 1. So you have negative 1/2 and positive 1/2 here. Next is to multiply 1/2 to R1 and add it to R2 for a new R2. So you have 1, negative 1. 1/2 times 1 is positive 1/2 minus this, 0. 1/2 times negative 1 is negative 1/2 plus this, another 0. This time you will have an equation x sub 1 minus x sub 2 equal to 0. Still, let x sub 2 as an arbitrary variable, but since we already used t earlier, let's use here s. So x sub 1 minus s is 0. X sub 1 is simply for what? Yeah, minus s equals 0 is s as well. So with this, our eigenvector for the eigenvalue, which is negative 1/2, is where you will have s and s. Once you factor s, you have 1 and 1. This is the more specific eigenvector, but of course there are a lot. And that is, or that can be enclosed into one form where you will have here s 1 1, such that s is an element of R but not an element of 0. Okay, so this is the eigenspace, eigenvector of the eigenvalue negative 1/2. So we are done with this, and again, simply understand how do we get this, because it's very important. And I reviewed the previous video, and we still have a lot more videos pertaining to eigenvalues, eigenvectors, and eigenspaces. Thank you very much for watching.